Hey there, Prof. Aram here, and in this video, I'm going to go over the concept of semi-annual coupon bonds. These are the bonds that pay the coupons in 2 installments per year. So every 6 months, you're going to receive half of the annual coupon for that particular year. As you know, for discounted cash flow analysis, your discount rate should match the periods. So far, when we looked at the examples of annual coupon payments, because the yield to maturity was an annual rate and the coupon rate is also an annual rate, and the number of periods are stated in years, so we didn't have to do any adjustment. But here, because the payments are paid every 6 months, we need to adjust three things. The first one is the dollar amount of coupons that you receive every period. Since you're looking at 6 months period, your dollar coupons are going to be your annual coupon dollars divided by 2. The yield to maturity is an annual rate. So to find the 6-month rate, you need to divide your yield to maturity by 2. And since your T is in years, for the case of semi-annual coupon bond, you need to multiply the years by 2 to find the number of 6-month periods to maturity. So you can modify the formula like this. Your payments are divided by 2, the coupons. Your yield to maturity or discount rate divided by 2. And your number of periods, your years, multiplied by 2. Same is true for the lump sum. The lump sum rate is divided by 2, number of periods is multiplied by 2. So let's look at an example. If an ordinary bond has a coupon rate of 14%, then the owner will get a total of $140 per year. But this $140 is going to come into 2 payments of $70 each every 6 months. The yield to maturity, which is the annual rate, is quoted at 16%, and the bond matures in 7 years. So your price in this case would be the present value of the coupons, which are $70 every 6 months. So $70 over your discount rate is going to be your yield to maturity divided by 2. So 16 over 2, 8%. So you will do 1.08 power of 1. And then this is for the first 6 months. The second 6 months, you will have 1.08 power of 2. And you'll do that for 7 years. So 7 times 2, you will have 14 6-month periods. So the last year, or the last payment would be your last coupon plus the principal amount, or 1.08 to the power of 14. So that's how we calculate the price of a semi-annual coupon bond. So let's find the price of this bond using financial calculator. First thing I'm going to do is to clear the time value of money, and the face value of the bond is going to be 1,000. It doesn't change whether you're looking at an annual bond or a semi-annual bond. The payments are going to be 14% times face value. This is the annual coupon that you will receive, but because this is semi-annual, we divide it by 2. So every 6 months we'll receive $70. Number of periods is 7 years multiplied by 2, because we need to find the number of 6-month periods, so 14. And then your rate is going to be the yield to maturity 16% divided by 2, because you need the 6-month rate. And then we can calculate the present value, compute the present value. So you should see a price for this bond that is $917.56. Let's look at the Excel sheet here. So for the Excel, I've already converted the rate, number of periods, and the payment. So yield to maturity is an annual rate. So you need to divide it by 2. So 16 divided by 2 is 8%. Number of periods is 7 years. So multiply that by 2 to get the number of 6-month periods. Future value is 1,000, no change. And then payment would be 14% multiplied by 1,000 face value divided by 2. So in terms of the pricing formula, you can have present value, which is the rate, 8%, which is a 6-month rate, 14 periods, payment would be $70, and then face value would be 1,000. So you should be getting $917.56. In fact, you can actually do this calculation here. So PV would be your rate, which was 16%. So 16% divided by 2. Number of periods is going to be 7 multiplied by 2. Payment would be 14% multiplied by 1,000, which is your face value, divided by 2, and future value would be 1,000. So you should be getting the same price. What I'm trying to say is that you can do your calculations within the formula as well. Okay, I hope you find this video useful, and thanks for watching.